Guys, welcome back to my channel. This is Tanzeel Mirza. Today we'll discuss one unique kind of algorithm, that is sleep sort. Most of the sorting algorithms that we know are comparison based, and by comparison based I mean each element is compared with its neighboring element and then swapped accordingly in the array. Sleep sort, on the other hand, is based on time. It is more related to your operating system task scheduling efficiency. We'll write the code and see how it works, but first let me give you an idea of its working. It's pretty simple actually. We have few elements, let's say 4 5 elements we have. So what we do, we'll run a thread for each and every element, and each thread will sleep for that number of seconds, whatever the number is, whatever the element is. That means if there is an element, say 5, then we'll create a thread for this 5, and this thread will sleep for 5 seconds. So this way, eventually all the elements will get printed once the thread sleep is over, one by one. So let's get started. Things will be more clear when we start programming. So let's get started. So we'll write our code in Java, and that's because I personally prefer Java whenever multi-threading is involved. Okay, so just make sure you have at least basic understanding of Java multi-threading. Very basic understanding will be more than more than enough. So there are two ways for creating a thread in Java. That is by extending the thread class, and the second approach is to implement the runnable interface. So we'll use the second one, the runnable interface. Okay, so let's get started. I'll quickly create one file. Okay, I'll call it sleepsort.java. In fact, let's open this file in VS Code. Okay, let me zoom in. Okay, class, and the class will be sleep sort, public static void main. Leave it like that. First I'm going to create a method, public static, return type will be void, and I'll call it sleep sort. This will accept array of numbers like this. For loop, iti, and it will run less than numbers dot the length. Okay, less than the length of this array, and then our I plus plus, increment the I. This method will create. I'm just going to create one variable of this type, a reference variable. Okay, sleep sort run, and we'll pass each and every element like this, and then the new thread I'll spawn sleeper dot start. Lots of errors. This is for. Okay, now I'm going to static let me close it here. No, yeah, public static, or not public static. I'm going to create the code. I'm going to write the code to implement the runnable interface. So what I'll do is static class sleep sort run, implements runnable. Okay, so this is what I created here. The instance of this class only I created here. So here I'll do val. The constructor I'll create. I'm going to create a constructor, and inside that constructor I'll pass this val. Okay, this dot val is equals to val public void run. So basically what I'm trying to do here is I'm going to run a separate program for each element. So that's why I have created a separate class, an entirely a separate class here. And what we have to do is the entire crux of this entire algorithm is to sleep for these many seconds. Okay, and just to make it convert this value into the milliseconds, I'll multiply this with 1000. Okay, and this dot val, and after that I'll just simply sys out this dot val, but this won't run like this. That is because we need to encapsulate this entire thing inside a try catch mechanism. So I'll quickly create one, and here we need to catch this exception. Throw new. I'll call it runtime exception. Let's create a instance of that only, runtime exception. Okay, that being said, what else is remaining? Yeah, now the why main, not name, it has to be main. Static void main string args nums is equals to, I'm just creating a list, let's say 5 3 6, not 6, and then 4. Okay, some default elements I have passed, and now I'm going to call this method sleep sort, and I'll pass this nums. Okay, that being said, I'll save the code. And now we'll have to run this program. Let's see. So no rocket science, let's quickly run this program. Java C sleep sort Java, and clearly there are some errors. First thing is this, I forgot to initialize this int I. And what else we have? This has to be nums, not num. What else we have? This has to be val, not va. Save the code. I'll clear this out, and then it's compiled. Java sleep. Hit enter, and let's see. 2, okay, 3, 4, 5. Awesome. So that's how it works. So let's just, for the sake of confirmation, let's add few more values. This time I'm going to give 7, 3, 6, 9, and let's say 4. Save the code, compile the program, and then run it. Let's wait. 3, 4, 6, 7, 9. Awesome. So that's how sleep sort works. And clearly there are some drawbacks, some major drawbacks are there. First drawback is you will have to wait for all the threads to complete their execution, okay, to complete their sleep time, their sleep cycle. Imagine you have elements like 3000, 4000, 10,000. So that's going to take forever to sort this kind of lists, such kind of array. Okay. So clearly it's not very time efficient. Also, it cannot be performed on a negative number. For example, you cannot sleep a thread for minus 10 seconds, minus 20 seconds. Okay. So that is one problem. So clearly there are some major drawbacks with this sleep sort. Okay. It's not very efficient algorithm. I'm not very sure about the use cases of this thing, but yeah. So that's all for today. In the upcoming videos, we'll cover few more strange and unique sorting algorithms. So in the meantime, you can comment about the implementation, your implementation on a different programming language maybe, or a different OS maybe. I'm on Linux. You may try this on Windows. So it entirely depends upon you how your operating system schedules the tasks. Okay, it depends on that. So also this is OS dependent and language dependent. Okay, the execution, how your programming language that you are using manages the thread pools and the threading processes. Okay, so in the meantime, you can comment about the your implementation and maybe some advantages or at least some of the use cases of this sleep sort. So in the upcoming videos, we'll discuss about some other unique and strange sorting algorithms. That's it for today. Thank you so much, guys. Thank you so much for watching this video. See you in the next video.